Dear students, welcome to MOOC course on NGOs and Sustainable Development. The topic today we cover environmental sustainability. This comes under chapter 30. Talk about this sustainability. There are different types of sustainability. One, we can say that very much important on economic sustainability, which defines the management of resources responsibly and efficiently. Economic sustainability is designed to support long-term economic growth without harming environmental, social, and cultural aspects of community. Social sustainability is focused to benefit the community. Sustainable life to individuals, families, communities, and countries means healthier air and sound personal healthcare systems. Exploitation of renewable energy sources such as solar energy, wind energy, and geothermal energy. This is said to be social sustainability, comes under this. Exploitation of renewable energy sources such as solar energy, wind energy, and geothermal energy. The primary objective of social sustainability is to reduce poverty line and to provide a better global quality of life, elevated literary level, and credible healthcare systems. The Earth's natural resources such as minerals, petroleum, coal, natural gas, the Earth biodiversity such as creatures including birds to insects and mammals have reduced in number due to accelerated population growth across the globe. The exploitation of Earth's natural resources is at a faster rate than they can be regenerated or replenished, thus pose a threat to environment. So environmental sustainability encourages individuals to live with harmony, integrated with knowledge to generate minimal solid and liquid waste, and sufficient awareness to recycle, reuse, and recovery of waste. Environmental sustainability is designed to improve the quality of human life without disturbing the carrying capacity of Earth's supporting ecosystems. The ultimate objective of environmental sustainability is to ensure that the needs of today's population are met without jeopardizing the ability of future generations to meet the demands. Hence, environmental sustainability is defined as responsible interaction with the environment to avoid depletion or degradation of natural resources and assure long-term environmental quality. Of course, you will agree that the environmental sustainability is defined in a responsible way of interacting with the environment without depleting or degrading the natural resources and to have ensure long-term environmental quality. This varies from country to country. Environmental sustainability, the yardsticks or parameters are said to vary from country to country. For example, in US, the Environmental Protection Agency enforces regulations that involve environmental sustainability and protection. The regulations cover air quality, water quality, soil quality, plant life, animals and wildlife habitats, terrestrial biodiversities, hazardous waste, greenhouse gas emissions. The importance of environmental sustainability, what is that? Now it has to be looked on. The general goal of environmental sustainability is to provide huge benefits to human health and all other soil and aquatic species. It reduces the global carbon footprint, and of course, you know that some of the carbon residues are left from the human activities or forms of carbon like carbon dioxide, carbon monoxide, probably that also add to this footprint, carbon footprint. And the objective of environmental sustainability is to reduce our dependency on fossil fuels and other harmful energy practices. Environmental sustainability can increase life expectancy by providing sound living conditions and better healthcare systems, irrespective of economical status of community people. Sustainable development encourages industrial production of products at enhanced rate without primary and secondary emission of hazardous industrial pollution. So that when you consider that a sustainable development, so we need industrial production of products at enhanced rate, higher rate we require, but of course without emission of primary and secondary products. It also encourages industries, MSMEs, traders and distributors, or sometimes we call it as government also, to draw out strategic plans for long-term benefits instead of aiming at short-term easiest and cheapest options. Commercial agriculture or industrial agriculture has the ability to produce abundant amounts of food at affordable prices, but the method of farming can be detrimental to the environment. So accelerated or commercial level of production of agriculture products sometimes end up with the detrimental or danger to the environment. So industrial agricultural methods are heavily dependent on chemical fertilizers and pesticides and exert high chemical load onto soil and aquatic sources. Also, commercial crops are often monocrops, which involves growing a single crop year after year. So this continuous the threat to the soil can lead to water pollution due to chemicals runoff into waterways, deplete the water resources owing to overuse, and soil erosion and poor soil quality due to aggressive crop planting. With environmental sustainable agricultural practices, farmers can minimize water use and lower the dependence on chemical pesticides and fertilizers, so that environmental sustainability integrated for agricultural practices so help the farmers can educate them to minimize water use and lower the dependence on chemical pesticides and fertilizers, so that they also can minimize tillage of the soil and rotate crop planting each year to ensure higher soil quality. So that education of the farmers on environmental sustainability start from the application of crops in rotational wise so to help this soil quality. What is the roadmap to achieve this environmental sustainability? How we are going to advocate to achieve this environmental sustainability? This is very important. So first we can say that reduce methane emissions by modified food intake style. So we have to change the food intake style so that emission of methane should be reduced. Second concept is lean on green energy utility concept. That is, instead of depending on renewable sources, you renewable or non-conventional energy sources such as wind, solar power and geothermal energy are all infinite sources and will not deplete. Cook and bake your own meals and snacks rather than relying on packaged food in plastic or non-recyclable the packaged materials, which causes huge environmental damage. So this can be avoided if you start cooking and bake your own meals at your own kitchen, and so that we need not depend on the food materials collected from this outside market, and so that plastic and non-recyclable packaged material can be avoided from dumping onto the open soil. Avoid drinking water in non-recyclable containers and drink from the tap. Directly you can take water from the tap or drinking sources, so which will avoid usage of non-recyclable containers. the off-life period of certain plastic materials is about more than 100 years, and so that instead of reusable water bottles can be used. Walk or bicycle instead depending too much on car. This avoids the depletion of mineral oil and reduces greenhouse gas emission and gains the scope for carbon credit. Carbon credit, we know that it is said to be a credit achieved by restoring the that is original condition of atmosphere. Similarly, rainwater filter jug may be a way forward for avoiding the consumption of water from the plastic containers. Replace tungsten filament light bulbs with more energy efficient electronic light bulbs can be used. And this provides better, healthier life with the desired light quanta. And practice to locally available foods instead of far transported foods. So now you have to generate or otherwise make use of the foods available within your near vicinity so that it will avoid the refrigeration energy, transportation energy and preservation chemicals. Also it avoids emission of greenhouse gases and hazardous gases. So you know that while you are transporting in the refrigerated containers, we have to use the refrigeration unnecessarily emit this greenhouse gases and hazardous gases can be avoided by making use of the foods available in the near vicinity. Resell, repurpose or donate unwanted excess foods. This is also important concept. So repurposing may mean using old clothes or bed sheets for cleaning racks or reusing glass jars to store dry foods. This can be a good practice. Replace plastic wrap with reusable beeswax eco wraps. Non-biodegradable plastic straw may be replaced by biodegradable plastic wrap. So what is the measure? How do you measure this environmental sustainability achieved by this public or industry or any community? It is given by Environmental Sustainability Index, abbreviated as ESI. ESI was created to compare the sustainability efforts and abilities of countries to achieve it. ESI helps at decision making by providing clear comparisons of environmental statistics. The basic assumption of ESI is to ensure sustainable development and the use of resources to meet societal, economic, and environmental demands for the long-term approach. For calculating or making up ESI, they used about 76 variables to create 21 indicators of sustainability. The indicators cover 5 important categories indicating the condition that is more sustainable. The first one is environmental systems. The systems maintaining and improve health of ecosystem. The second important the condition reducing environmental stress. So reducing anthropogenic stress on the environment. This is considered to be the second important the condition. And third important one, reducing human vulnerability. Some of these parameters having fewer negative impacts on people from the environment. So this also take into consideration while drawing this ESI. Capacity to respond to environmental challenges. This is important one. Fostering social infrastructures thus establish ability and strength to respond effectively to environmental challenges. The environmental challenges lies increase in thermal or wind or outside temperature conditions. So that has to be controlled by social infrastructures. That is all the fourth important condition. And fifth one is global stewardship efforts, cooperating with other countries to address environmental problems. So not only we become leader in that, and it has to be must or mandatory to help the neighboring countries to also address the environmental problems. The ESI scores range from 0 for least sustainable parameter to 100 most sustainable countries and is an equally weighted average of 21 individual indicators. Already we listed that 21 individual indicators, out of which now this has been mandatory made a parameter ranging from 0 to 100. Each country has its own environmental priorities, attitudes, opportunities, and challenges to fit within this range of parameters like 0 to 100. For example, the United States scores high in the capacity to respond to environmental challenges. They are very good in adjusting with the environmental challenges, but they are low in actually reducing environmental stress. So that's what I say, that it is varying from country to country, and only thing is we see that how far we are fit into that range of these scores. The ASI scores have created some healthy competition between nations. That is a very good move. That is, they have developed a healthy competition between nations. No one wants to be seen as underperforming compared to other countries. Countries dissatisfied with the ranking have also begun to refine their environmental data accessible to increase their score. This is what a continuous practice to increase the score in order to be par with other countries. So far, we have been discussing with environmental sustainability for a community or for a country, or we can say the domestic sector. And another illustrative example I have taken for the environmental sustainability for the industries, and particular case study I have taken that the environmental sustainability of leather sector in India. So now, not only this, the the industry to sustain, we have to take care of the environment. Anything endangering the environment which causes the sustenance as a question mark for that particular sector. This is applicable to other industrial sectors like the textile sector, pharmaceutical sector, and slaughterhouse sectors, and many sectors are available, of which just I consider that the environmental sustainability of leather sector, how this leather industry or leather sector has worked to get this environmental sustainability in order to be in the market, global market, and also domestic market. Indian leather industry is recognized as the most promising foreign exchange earning sector since early 1970. In terms of percentage share, leather export earnings accounted for about 7% of the total foreign exchange earning sectors. In 1989 to 90 score, it is 7% of it. And it was occupying 7th place in terms of export earning in India when the first environmental ban was imposed by its major export absorbing country, Germany. Because that time the industry was utilizing pentachlorophenol as a preservating agent, and since this buyer from the Germany and they objected the presence of pentachlorophenol in the finished leather, and so that they put a ban on importing leather from India. So that time India, that is leather sector in India, was facing lot of challenges. However, even after 10 years, that is after this 10 years in 2008 and 9, with annual earnings of about 7 billion US dollar, the industry has reached such a credible height of success, which made it sixth largest foreign exchange earning country in the world. Earlier they were in India rated at fifth. Now after many strides, they went up to this sixth largest foreign exchange earning country in the world. On one side, we say that the industry is export generating potential to boost the growth of the economy of the country. On the other side, the pollution intensive nature of the industry. This made the sector very distinct among other sectors in the global level. The Indian leather industry has been hit by several foreign environmental bans and domestic environmental regulations since 1990s. One hand we say that has been banned, hit by many several foreign environmental conditions, and another one more, our own domestic environmental regulatory bodies also put a ban on this industry. The ways of compliance adopted by the firms and interventions made by the government have helped the industry in restructuring its technology. And Perhaps as a consequence, an apparent growth in export sector has been experienced. That's why they had to modify the in-house practices or in-house technologies that change the technology in order to par with the other countries. And also they were concentrating on environmental management so that the export sector has been slightly affected. This again challenged many so-called hypotheses which show a trade-off between environmental compliance and export competitiveness and supports Porter's hypothesis. According to this thesis, strict environmental regulations do not inevitably hinder comparative advantage against foreign rivals, rather often enhance it. So that there is no trade-off. They are not went off the trade and they were still trying to manage this environmental that is issues, and at the same time they were concentrating on the leather production or otherwise in order to be in the global market. The environmental standards imposed on leather industry and thus consequential impact on export prospect of Indian leather industry was realized. So Indian leather industry realized that now they have to manage this environmental these standards on leather industry, so that they went for, that is worked hard in order to reach this impact on the export sector of Indian leather industry in respect to environmental compliance was studied. So the work, or otherwise we can say that they resourced many technologies and in order to upgrade the environmental compliance of the industry. Major spatial concentration of tanneries and production units in three states, namely Tamil Nadu, Uttar Pradesh and West Bengal. Tamil Nadu has the highest export generating capacity. Capacity wise, Tamil Nadu has the highest and about 34.88%, and followed by Uttar Pradesh, which has got 28 to 25%, and West Bengal 15.75%, 76%. So they have got a spatial concentration is more in Tamil Nadu, and so that compared to other sectors, it is climbing more on this. And of course, if you see that the management of environmental norms can be better illustrated by per tannery export generation ratio, how much they can able to export. So in the case of generation ratio, the tannery export generation ratio is highest for Uttar Pradesh, it is about 1.99, followed by Tamil Nadu and West Bengal. Capacity wise, Tamil Nadu is more, but export generation wise, Uttar Pradesh is more. That's what we can say, that the environmental compliance or environmental management within this leather sector, which makes the industry to export or generating capacity is said to be increased. And this is what clearly show that the export plant ratio also follows the same trend, highest in Uttar Pradesh, followed by Tamil Nadu and West Bengal. That's what we can say, that export potential with the plant capacity is said to also be more with Uttar Pradesh and compared to Tamil Nadu and West Bengal, because the environmental regulations and environmental compliance are restriction on the industry is very less on Uttar Pradesh, whereas more in Tamil Nadu. Indian leather industry is dominated by large numbers of small and tiny producers, and therefore the availability of finance turn out to be a major constraint for them to follow the stringent environmental norms. The share of environmental compliance cost is 2 to 5% of export value of leather and 1 to 3% of export value of footwear and other leather products. These pollution control measures has been found to be inadequate, and that resulted into closure of a number of tanneries due to failure of environmental compliance. In continuation of this, India's leather exports share consistently declines till 1996 to 97, and then it followed a consistent steady trend. This indicated the failure of export-oriented units of leather industry to comply with international environmental standards along with other quality standards. Already mentioned that the usage of certain chemicals made them to ban this import of leather from India. So one I already told you that PCP was one major issue, that Germany banned this import of leather, and afterwards the application or usage of azo dyes was also banned by many of these foreign countries. So that's what also made this ban or restriction on the import of leather from India. And also another contributing factors, the speed of progress of giant foreign competitor like China in keeping those standards. So that's what they are also competing with India, and so that their export to countries were restricted or reduced. India consistently lost its export market during the phase, while China started grasping those markets with accelerated phase. However, besides China and India, the global trend of leather exports was being influenced by few other countries like Italy, Hong Kong, Germany, France, Brazil, Belgium, though China remains the dominant player. So India was phased out for a certain period of time because the environmental complaints they could not make, and so that they could not able to meet the standards prescribed by this foreign buyers, and so that they could not able to keep up with the China and other countries. India had to refine the environmental management in leather sector. That's what they made them, drive them in order to refine the environmental management as the leather sector with the support of technologies developed by National Research Institute like CLRI, Central Leather Research Institute. So they realized that unless they modify or unless they redefine this environmental management in leather sector or in industries, they cannot able to compete with the other countries. So that's why they sought the help of the National Research Institute CLRI in order to support the technologies to upgrade the environmental management in the sector. So when you consider that leather industry has this processing of the leather from raw hides to finished leather. This is a basic concept or basic conversion of the raw hides and skins to finished leather. This involves three stages. Yeah. First stage involves pre-tanning stage of hides and skins from domestic stock market, bovine animals, sheep and goats. The second stage includes conversion of pre-tanned rawhides into tanned hides leather. The third stage involves conversion of tanned hides and skins into finished leather. These are the three important stages. However, the actual pollution loads depend upon the levels of environmental standard and the extent of compliance attached with this. Out of these three stages, the first two stages contributing more pollution load compared to third stage. And third stage is a less polluting, but of course it's a labor intensive and high value added segment. And when it comes to this industry, this is the picture that I showed here, and the industry receives the raw material in the wet salted condition. So as soon as the animal skins or hides are flayed from the animals, they apply sodium chloride or salt in order to preserve the raw skins and hides during storage and transportation. And the raw hides or skins are converted to finished leather by addition of chemicals. So input would be chemicals and water, of course fresh air for the laborers to work on. So these are the essential commodities for conversion of raw hides and skins into finished products, maybe wet blue, crust or finished leather. These are the products that can be obtained from the raw material. And during the conversion of the hides and skins into the products, they discharge wastewater or called effluent, and which requires further treatment. Without treatment, they cannot be discharged into the open land. And of course, air pollution are also emitted, or air emissions are during the conversion from raw hides to product. And of course, solid waste generation from the industry or conversion of raw hides into products generates a solid waste about 60 to 70%, that I can take in data. And when you convert this 1 ton of wet salted hide and amount of chemicals used, we can see from here, chromium oxide about 25 kilogram per ton of it, out of which 12 kilogram is retained by the leather and 13 kilogram is wasted into the wastewater, or otherwise goes into solid waste. And organic tannins about 25 kilogram they use, about 20 kilogram is being absorbed and 5 goes into the waste. Fat liquors about 22 kilogram total, out of which 17 is fixed with the leather and 5 kilogram goes as a waste. Dye stuffs, you see that 5 kilogram applied, 4 kilogram is absorbed by the leather and 1 is in the waste. Acid base salts, what they use about 191 kilogram, and 191 kilogram of the acids, bases and salts completely discharged into this wastewater. So this contribute to high TDS of wastewater, because we say that a tannery having high TDS or otherwise total dissolved solids of the tanning sector is very high, mainly due to this factor. And surfactants, they apply about 3 kilogram, and all the 3 kilogram of surfactants is discharged into the wastewater. That's why the tannery wastewater is said to be foaming, or the excessive foaming is observed on this discharge of tanning wastewater. Enzymes, they use about 5 kilogram, and out of which same 5 kilogram comes to the waste. And finishing products, total we say that 100 kilogram, out of which 12 are said to be fixed into this, and 88 kilogram of chemicals are coming into the waste. So total, if you see that, 452 kilogram per ton of raw material to be converted they use, out of which only 72 kilogram is said to be fixed onto the leather, and remaining 380 kilogram of chemicals are coming into the waste. So that's why you say that the leather sector or leather industry is, of course, is contribute more to this national economy, and at the same time it is high in pollutional aspects in terms of liquid waste as well as solid waste, and some of them are said to be in the gaseous waste also. In this particular slides, I just take 2 slides to teach you that how this leather is being manufactured. And as I told you earlier, the industry receives this raw material in the wet salted condition. The first step is to remove the applied sodium chloride by soaking it in water, plain water. The wastage of water or wastewater discharge from this section is called soak liquor. This is a section, or this soak liquor contains high amount of sodium chloride. And next section is application of lime in order to loosen this hair on the raw material. And after this section, it goes for annealing. It is nothing but removal of air from the raw material. And further this reliming, it is again application of lime in order to again loosen, or otherwise we can say that flux the raw material. And after which it goes for removal of the loosened flesh on the surface of this raw material. So that here generation of animal fleshing as a solid waste, hair from this raw material considered to be a solid waste on this. And followed by this, because the early 2 stages, liming and reliming, they were adding lime or as calcium oxide were added, and this causes this brittleness to this leather. So in order to remove that excess lime, they apply ammonium chloride or ammonium sulfate, and this process is called deliming process. And this wastewater comes out of it is called delime liquor. Since they applied this ammonium salt, and this section wastewater contains high amount of ammonia stripped to this atmosphere as a gaseous emission. And next stage is called a pickling, that is making this the raw material in order to go for tanning. So this step is called a pickling stage. They apply sodium chloride with acidified, or otherwise acidified sodium chloride is said to be applied in order to make this raw material into receive the tanning material. So that's why it's called pickling stage. And where this wastewater discharge is called pickle liquor, and it's highly acidic and having sodium chloride and sulfuric acid as the main component of the wastewater. Next stage is a tanning. It is nothing but making this leather. So far we can say that it is a biologically or microbiologically affected leather and made it resistant to microbiology during the storage or the use, and it's called tanning. And for this purpose they apply basic chromium sulfate or as vegetable tanning as the tan. And the wastewater discharge from this is called a tan liquor or chrome liquor, accordingly the basis of tanning material used. And after this is very simple, that goes for this shaving, that is in order to reduce the thickness of the leather they shave this, and the waste generated from this section is called chrome shavings, which is required to be treated. And followed by this the retanning and dyeing and fat liquoring. So this section wastewater is a complicated wastewater. Of course this the wastewater called retanning wastewater, followed by this neutralization including washing, and of course rest of the sections are called wet finishing and trimming. The side ends can be removed, that's called a trimming as a solid waste comes out. And after this the flesh side will be completely buffed, or otherwise you can made uniform, and during which case the emission of solid waste comes out is known as buffing test. Now finishing of this leather with this solvent, and they can be added in order to keep the liquor, or otherwise it's called as liquor, onto surface of it in order to protect from the environmental conditions they apply at the finished coat. And now we can see this the flow sheet given. As I mentioned that the wastewater discharge from the industry soak liquor, lime liquor and de-lime liquor, pickle liquor, chrome liquor, retan liquor, dye and fat liquor. These are the sectional streams comes from the industry. And first they say that they segregate the soak liquor and take it for evaporation, the solar evaporation pan. So this is a sectional stream is separated out. And pickle liquor and chrome liquor are segregated and goes for chrome recovery unit or chrome recovery. From this spent chrome liquor, they do that separation of chromium called chrome recovery. And after separating the soak liquor stream, pickle liquor, chrome liquor, left out with lime liquor, de-lime liquor, retan liquor, dye and fat liquor. All the four streams are said to be combined or make it as a composite. And this composite wastewater passed through the screening to remove the coarse or floating solid and made it equalized and go for the primary clarification to remove all the suspended solids present in the wastewater and enters this biological treatment and followed by the secondary clarification. Now it is fit for discharge. And the sludge generation from the primary clarifier and the biological wastewater treatment clarifier are said to go for this sludge dewatering. The important should be noted here. Now the industry could not meet the environmental standards prescribed by the Pollution Control Board. So they had to refine this. That is the reason I said that initially in 1990s they suffer a lot on this export because of non-compliance to environmental standards. Say they worked and sought the technologies from CLRA and refined the effluent treatment sections. After which you can say that the soak liquor, I said that initially they segregating the soak liquor and now we devised a technology in order to go for the separation of suspended solids from the and removal of the contaminant from the soak liquor, and the treated soak water or wastewater of this kind will pass through this membrane separation process for take out the excess water, and it is crystallized in solar evaporation pan or mechanical evaporator, and this can be made use in the tanning process itself. So this a closed loop arrangement has been made for this treatment of soak liquor. This is one important development made by this industry and implemented in the industry. And another one more industry, that is product, I said that the chrome recovery. And this is a spent chrome liquor comes out from the tannery. They collect it and pass through the screen to remove the floating solid. And this is the collection tank where they add magnesium oxide to precipitate the chromium as chromium hydroxide. And further to dissolve this chromium hydroxide, they add sulfuric acid and convert this as a basic chromium sulfate, and recovered chromium can be made use within this industry. After this particular flow sheet has been made, after implementing this technology, the industrial image has been increased. So far they were considered to pollute the environment by adding this chromium, but because of this, the intervention of this closed loop arrangement, the emission of chromium from the industry has been completely eliminated. And one step ahead of it, and now the supernatant contains magnesium sulfate and some of the residual organics could be removed by pressure sand filter and improvised the heterocatalytic reactors, by which they could able to treat this entire the dissolved organics present in the wastewater and get only magnesium sulfate, and this magnesium sulfate can be dried out or crystallized and made use in the further uses. And this is again improved the image of the industry in the global scenario. And another important thing, I already mentioned that de-lime liquor which was used, or de-liming is nothing but application of ammonium sulfate, ammonium chloride in order to remove the adsorbed calcium from the raw materials. And for that they were adding ammonium sulfate and ammonium chloride, and this was the source for emission of ammonia from the industry. So this was removed by this flow sheet developed by this in the CLRA, and the de-lime liquor was treated with acidic magnesium phosphate to convert this ammonium into the struvite, or this crystal can be separated out and it can be used as a manure, and this supernatant can be converted or it can be combined with this other streams for further treatment. And so after this implementation of the treatment technologies, now already mentioned that soak liquor segregated and went for the treatment by this flow sheet developed by CLRA and evaporated solar evaporation pan, and the salt is meant for reuse within the industry. and pickle liquor, chrome liquor combined to go for the chrome recovery, and further supernatant is that is treated to get the magnesium sulfate. So that this stream also completely eliminated from the endangering problems. And D-lime liquor already mentioned that it has to remove this lime, that is ammonia, for the resource processes like manure preparation. And the supernatant of lime liquor and D-lime liquor combined with retan liquor and dye and fat liquor. These are the four liquors as mentioned earlier we get. And the new flow sheet followed by this, the retan liquor and dye fat liquor combine and go for a special treatment developed by CLRA, and this wastewater will be combined with the lime liquor and D-lime liquor without addition of external the specifying agents, and we can able to reduce the pH, because this is said to be an alkaline range and these two wastewaters are said to be acidic range. Made use of this the component without addition of external chemicals, and so that this is equalized, and go for this technology developed by CLRA and treat up to this the supporting the membrane separation process. So using this RO, reverse osmosis process, we could able to that is get the water for reuse purpose for the tannery. The water is being used and the salt comes out of it. The reject comes out of is evaporated in multiple effect evaporator and get this purified salt, and the salt could be used in the industry itself. So that's what they say, that the industry after secondary biological treatment of this technology developed by CLRA, it was used for this the membrane separation process called the reverse osmosis process to recover water, and the water recovered can be made use for industry process again, and the reject comes out of the RO process is evaporated in multiple effect evaporator used in this industry, and the salt that is coming out of this multiple effect evaporator can be used back in the industry, and so that the problem of the salt emission or the TDS emission from the industry is completely eliminated by the development or implementation of the technology developed by CLRA. And of course, one more the problem they face with this solid waste generated in the leather sector. This is another issues of this industry or leather sector not to function, because 1 metric ton of wet salted hides and skins yield about 300 kilogram of leather. We say that only 30% of the realizable finished material is obtained, and remaining 70% of the material is turned to be 250 kilogram of tanned solid waste and 350 kilogram of non-tanned solid waste, and another 100 kilogram raw material is lost in the wastewater. This is the component of it. The solid wastes are distributed as animal flushing. Already mentioned that it is coming out in the second stream of it, contributing about 56 to 60% of the total solid waste generated. Chrome shaving, chrome splits and buffing dust contributes about 35 to 40% of it. Skin trimmings about 5 to 7%. Hair contributes about 2.2 to 5%. So in the global level, if you see that, and 1643 tons of the solid waste is generated per day across the globe. In India alone, about 800 tons is being produced per day. So such a concentration or otherwise the solid waste are generated from the leather sector. The animal fleshings made use for recovery of biogas from it, and this technology was implemented in industrial clusters to remove the menace of this animal fleshing. Another one more, after fermentation of this animal fleshing, whatever the digested comes out of it, the residue comes out of it, is used by this vermicomposting of this fermented animal fleshing, and the vermicomposted material may be made use for as a fertilizer, organic fertilizer for the agricultural sector. And this is another one more big breakthrough made in this leather industries. The tannery solid waste undergoes fermentation using microbes. Separated or known microbes were used, and converting this the solid waste into hydrolyzable compound. And after this chemical or biocatalytic treatment, and this fermented material goes as to produce biodiesel, and further of it could be developed into bioethanol and biohydrogen and biomethane. All the products can be made from the fermented products of tannery solid waste. The biodiesel developed out of it can also go for decarboxylation, can get biopetrol. So that biofuel and power generation is a good concept for the solid waste generated from the tannery waste. And probably the biofuel developed out of this, the tannery solid waste, could able to run this, the road transport as well as now they have said that aviation fuel also could be made out of the ternary solid waste. This has been proved. And acid protease from proteinaceous animal solid waste. This is also another breakthrough made. Enzyme production from the proteinaceous animal solid waste like animal fleshing was also made out of this solid waste. Another one more thing, the bacterial inactivation or otherwise that is microbial protective agents like proteoglycan production from ANFL or animal fleshing was also recorded as a breakthrough in this field. And the chromium containing solid waste were converted into the pavement material, that is the chromium containing solid waste generated from leather industry was converted to pavement material. This is also important breakthrough made for this management of solid waste in leather sector. And to summarize this, so far what you mentioned that the environmental sustainability recorded or required for this the domestic sector and environmental sustainability required for this industrial sector. Just I summarize this: climate change, poverty, inequality, hunger, and multiple other global challenges continue to hamper our journey towards a sustainable future in domestic sector. And similarly, industrial competitiveness or business confronting a challenging phase due to environmental damage caused by manufacturing process. In this regard, can focus on environmental sustainability to elevate the life expectancy of people and develop harmony with other countries. Consistent attention is required on environmental sustainability of industries to sustain their export and indigenous market at the positive growth rate. So, in order to be in the global market or leader in the global market, the sustainability of the industry on environment is very much desired so that their image will also be improved in the global sector. Thank you very much.